Good morning, everyone. My name is John Walsh from the National Center of Emergency Preparedness at Vanderbilt University. And on behalf of the Tennessee Department of Health and the Tennessee Hospital Association, we want to welcome you today to the webinar regarding decontamination issues affecting hospitals and healthcare facilities. This is an issue that is I think dear to the hearts and minds of everyone in the healthcare industry. We're going to talk a day about general decon, but we're also going to focus primarily on methamphetamine issues and some of the case studies and incidents that you run in contact with throughout the state. Obviously, the meth problem in Tennessee is an epidemic as well as it is nationwide. It's a battle that we all face, and it's a problem that is totally debilitating to the individuals that get hooked on this stuff. So it is a problem throughout the state. Hospitals and pre-hospital personnel run into these particular situations on a frequent basis, and hopefully we can clear some mess that has occurred about decontamination in these kinds of incidents. So today we have two very knowledgeable and experienced speakers. The first speaker will be Dave Shelton, who's a retired special agent with the U.S. Drug Enforcement Administration. And Dave spent a considerable amount of time in this particular region in North Carolina and Tennessee. So he also was a former TBI agent, so he's very familiar with the issues here of methamphetamine operations in the Tennessee area and this particular region of the U.S. The second speaker we have is Dr. Sullivan Smith. He is a physician with the Cookeville Regional Medical Center and also is part of the Cookeville PD Special Operations Group. He's extremely familiar with the both the operational and the emergency department operations dealing with meth. I think you're going to find both of these individuals extremely interesting. Afterwards, what we will have is a short period of questions and answers, and you'll be able to type your answers on the screen, and then we will take those and have our panelists today answer those questions for you. So we thank you all for attendance. I'm going to turn it over to Dave Shelton right now. So, David, if you'd like to go ahead and start with your presentation, we'll get things rolling. So, thank you.
Thanks, John. I appreciate the opportunity to be here. Actually, I'm very excited. I've done quite a bit of training over the years, but very rarely get to address a bunch of grown-ups. It's usually a bunch of cops. So I appreciate the opportunity to talk to y'all. I hope I don't foul this up. I'm kind of dumbfounded by the technology, and I'm just amazed that I can be sitting here in my underwear drinking a Bloody Mary and talking to such a distinguished group. Well, really, I'm kidding. I'm not in my underwear. But what I want to talk to y'all about today is I'm going to want to give you a feel for what a meth lab really is. I think, they are potentially extremely dangerous. There are a lot of issues that we have to deal with in the law enforcement arena as far as contamination, because we're in more of a position, or I was, the law enforcement officers are in more of a position to actually have more chronic exposure and more toxic levels of exposure that probably you'll encounter in an emergency room setting. So I want to talk a little bit, just explain to you kind of how meth is made, what is there, give you a little bit of an idea of what the most current issues are as things have developed over the last 15 years or so. The processes have changed, and really the meth manufacturers have moved to a process that is so incredibly simple and incredibly dangerous that probably in the emergency room setting you're going to be more likely to see issues relative to burn victims than you are contamination issues. But anyway, having said that, I'm going to try to start my PowerPoint. And come on, David, make your PowerPoint go. Here we go. I was a TBI agent back in the late 70s and early 80s, and occasionally, very rarely in this part of the country, would we encounter a meth lab. And when we did, it was of this variety, the biker gangs organizations. You know, they occasionally they would move into Tennessee. I think maybe twice in the 8 years I was with TBI in the late 70s and early 80s. We encountered meth labs in Tennessee, and they were of this variety, the P2P method. It's nothing near like what we see today. The old P2P method, first of all, it required a person that had some level of sophistication as far as ability to deal with chemicals, to do real chemist stuff. It didn't require really a chemist, but it took somebody with enough sense to know how to do some things that the guys that we see now just don't have. It required sophisticated glassware and difficult to obtain chemicals. And back in those days, usually, they were manufactured in huge quantities at a time. 10, 15, 20 pounds was not uncommon. Well, what happened was in the mid-'80s, some of the federal laws changed, particularly making the chemicals harder to get. And they enacted sentencing guidelines that pretty well meant when somebody was arrested federally with a meth lab, they went to prison, and generally for quite a long time. As a result of that, the meth labs pretty well disappeared in the United States, or at least diminished greatly, and the Mexican drug trafficking organizations that have always been kind of entrepreneurial drug dealers, you know, having been involved in cultivation and importation of marijuana and the cultivation of opium poppies, manufacture of heroin, and so they stepped in to fill the niche that the domestic manufacturers had left. And the Mexican drug organizations, and I don't know why, and I'm not sure anybody knows why or how they came about, using a new method, not the P2P method, a new method of manufacturing meth, which involved ephedrine or pseudoephedrine. Their method was called, it's a pseudoephedrine reduction method, and it was much simpler than the old P2P method and resulted in a much higher quality drug, a much more potent form of methamphetamine. Well, somewhere, and they were making huge amounts, they would have warehouses that would have huge vessels to cook meth in, and making 50, 100, 200 pounds at a time in numerous different cooking vessels. Somewhere along the line, someone, probably a toothless redneck from Coffee County, figured out that you don't have to start a manufacturing process using this method that the Mexicans were using. You don't have to start out with 50 pounds of pseudoephedrine. You could just as easily start out with 5 pounds or 5 ounces or 5 grams, as long as you reduce the quantities of the other chemicals necessary by the same ratio. And so what we saw, beginning really in the early 90s, mid-90s for sure, but out on the West Coast in the earlier 90s, was a resurgence of domestic meth manufacture. And people were using this new method called, primarily in the early days, called the red phosphorus method, which involved pseudoephedrine, red phosphorus, and iodine crystals as the major chemicals, pseudoephedrine being the precursor and the other two being the essential chemicals for this process. Followed very soon by another process referred to most often as the Nazi or anhydrous method or the Birch method, which also used pseudoephedrine or ephedrine as the precursor chemical. And the other essential chemicals were sodium or lithium metal and anhydrous ammonia. Both of them very easy, both of them made very high quality meth, and both of them you can make it in any size of batch that was convenient. Ultimately, in areas like Tennessee and other areas where in 1995, 2005, some laws were passed making it a little more difficult to get pseudoephedrine. The homegrown cooks, the local meth cooks, started using what we see today, which is essentially what they call the one-pot or shake and bake method. It's the one that you folks will be dealing with primarily anymore. The biggest problem that facilitated, the biggest things that facilitated the meth problem in the United States, and particularly Southeast Tennessee is one of the highest volume manufacturing areas around, are these. The cooks are smaller. Anybody can come up with $50 or $100 to go to Walmart and virtually buy everything they need to make a batch of meth. The recipe is incredibly simple. All three of the recipes I mentioned, the Nazi method, the red phosphorus method, and the one-pot method, are incredibly simple. That basically, if I had an hour to show you how to make a batch of meth, you'd probably be able to do it if I just showed you once or twice. Well, too, I've often, compared it to Grandma's cornbread recipe. If you watched your grandmother make cornbread a couple of times, you pretty well have it down and can make a batch of cornbread pretty much like your grandma's. So that's what we've seen in Southeast Tennessee, and actually most of the country now, is this ability to manufacture meth based on its simplicity, the attitude of most meth cooks to share their knowledge in how to make meth, which is kind of an odd thing in the whole realm of the drug world. Typically, people are protective of what would be considered their money-making scheme, which would be selling drugs, in this case making drugs. But what we found is most of the meth manufacturers are meth addicts, and most of them's life revolves around making meth and using meth. And most of them make a little meth so they have some to sell and some to use or to give to their girlfriend or wife or husband or whatever, and sell some to buy more chemicals to make more meth so they have more to use, and a little to sell so they can buy more chemicals. So that's essentially the reason that we have the meth problem we do. I'm going to walk you through fairly quickly the processes. And as a general rule, I don't show many videos when I'm doing a presentation, but generally I'm standing in front of the crowd, and I've got props to show to explain how things go. But I'm going to go very quickly through the red P and the Nazi method, and then we'll discuss the one-pot method, the one that's most prevalent now. And I'm going to show you a quick video on how the process works, and you'll see why you are going to have, we'll show you two videos. One's very short, one showing you how the process works, and one showing you what typically happens at some point in a meth cook's life when he's using the one-pot method. And then I'm going to turn the presentation over to Sullivan, Dr. Smith, who is, I've already told him, the fourth smartest doctor I've ever encountered. The first three cured me of cancer last year, which is why my mouth may get a little dry during the course of this presentation. But God gave me three brilliant doctors who fixed me right on up. So Sullivan has to settle for number 4. Okay, the first thing, the quick chemistry lesson is the difference between ephedrine and pseudoephedrine, which are basically chemically the same. They're oriented, as the chemist would say, those atoms are oriented a little bit different in space, but they are essentially the same number of hydrogens, oxygens, and so forth. And in the processes that we're seeing used today, all of them involve knocking one oxygen atom off of the molecule. That's it. That's the only difference between methamphetamine and pseudoephedrine or ephedrine. In 1995, I came back to Tennessee. I'd been stationed in Nassau, Bahamas. Somewhere up in Washington at DEA headquarters, there's a brain trust who studies trends in drug trafficking, what's going to happen and how and what to expect. And about the time I was coming back from the Bahamas in 1995, the brain trust said that in the near future, all I would be doing would be working methamphetamine labs. I figured that at that point I had been involved in drug enforcement for about 15 years, 18 years maybe, and I'd seen 2 or 3 meth labs in my entire career, 4 maybe in my entire career, and I thought, you know, there's no way that's happening. Well, by about 1996, I found out I was wrong and they were right, because this type of meth lab right here inundated southeast Tennessee. A simple process, and it spread so fast there was just nothing we could do about it. It was bizarre. And it was like the biblical who beget who tree in southeast Tennessee, and to some extent middle Tennessee. You would arrest a meth cook, and he would tell you about all the people that he learned from and all the people he had taught, and it spread exponentially. One would learn and teach 5, and each of those would teach 5 more, and each of them would teach 5 more. And this is the method that we're using right here in this part of the country. West Tennessee, they were using the Nazi method, and I'll discuss it very briefly in just a minute because I will take up a lot of Sullivan's time. But to do this process, the first thing we have to do is, we would have to do using this process was extract the pseudoephedrine from the tablets. And that was an extremely simple process that involved soaking pseudoephedrine tablets in methanol. These people would take a jar and put methanol. They would typically get it from heat, fuel line, antifreeze, and put it in the jar and soak these tablets. And the pseudoephedrine would dissolve in the liquid, and the binder would settle to the bottom of the liquid, and all they had to do was pour the liquid through a filter to separate the binder out, and they would end up with a jar of methanol with pseudoephedrine dissolved in it, or ephedrine dissolved in it. Back in about the 1996, 1997 period, we started seeing an inordinate number of unexplained fires and explosions. Because to get that ephedrine out of that racing fuel, these guys were heating it and evaporating the liquid in the microwave. I had one, actually, a state trooper called me one day and said, "David, we've had a fire in a truck going down the highway just outside of Dunlap." And the fellow had set himself on fire because he was evaporating his racing fuel in a jar. It was in a jar, and he was evaporating it with a propane torch. So assuming that we successfully extracted our pseudoephedrine without burning ourselves up like that poor fellow did, we will add that to whatever vessel we're going to cook in, usually a coffee pot. And to that, we're going to add our second ingredient, red phosphorus, and our third ingredient, iodine crystals. Most of the time, these guys would get their red phosphorus from the match strikers on matchbooks and either scrape it off or soak the strikers in alcohol, and that would dissolve the adhesive, and the red phosphorus would fall to the bottom of whatever they had it in. They would get iodine crystals at a tack shop, farm supply store, typically used to treat hoof disease in horses. But there were other sources, water purification and so forth, for the iodine crystals. So I'm going to put roughly equal parts of these three things in a cooking vessel, usually a coffee pot. I'm going to add a little water and add heat to it. I don't have to add the heat. It'll cook by itself. But if I add heat, it'll do it more quickly. And in a fairly short period, anywhere from 30 minutes to sometimes several hours, depending on the heat and the quantities of the three chemicals that they put in there. In a few hours, what I'm going to end up with is kind of a dark red sludge. It has the methamphetamine oil in it. I'm sorry, my mouth's a tad dry. I'm going to filter the sludge, and I end up with a jar of meth oil. To that meth oil, I am going to add lye water. So these are the chemicals you're seeing in the standard red P-Lab, and they still exist. There's still a few of them out there, but not as many as there were at one time. I'm going to add lye water to change the pH of the oil I have, and then I'm going to add usually a petroleum-based solvent, most commonly Coleman fuel, but occasionally I'll use ether. And when I add that to the liquid, the methamphetamine that I've manufactured is absorbed into the solvent, to the usually Coleman fuel or substance like that. Then we'll take muriatic acid, sulfuric or hydrochloric acid. I could use either one. And I'm going to add either aluminum foil or salt, rock salt, to it. And I'm going to create hydrogen chloride gas. And I'm going to bubble that through a hose. I'll put a hose on the container so that this gas comes out as it's converting the acid into hydrogen chloride gas, and bubble this through the liquid. And it'll cause the methamphetamine to recrystallize and settle at the bottom of the container. So those are the chemicals that I was exposed to while I was making methamphetamine. As a result of this manufacturing process, I'm going to be contaminated with the fumes and the byproducts of this process. I'm going to be contaminated with methamphetamine because actually in the manufacturing process, methamphetamine is released into the air in very minute quantities, and it's going to settle on my clothes and skin, but it's going to be in just very small trace amounts. And I'm going to be exposed to some other byproducts of the manufacturing process, this manufacturing process, including one called phosphine gas. During this manufacturing process, using iodine and red phosphorus and pseudoephedrine, I'm generating phosphine gas. Typically, not at such a high rate that it would do like it did this fellow and kill me, because I'm generally making it in very small quantities, and usually if you have any any type of ventilation at all. It does not reach the level that it will kill you, but it's not good for you. You know, all of those things in the atmosphere are measured in parts per million, and I believe that the parts per million that they have figured out of exposure to phosphine gas in the atmosphere, not necessarily fatal but harmful, is 50. 50 parts per million phosphine gas in the atmosphere is considered harmful. That's like having a room the size of, oh, I don't know, probably your living room filled with ping pong balls and having 50 blue ones in there. And so that small amount is enough to be harmful to human beings. So among the things that the people you may be dealing with will be coming into the emergency room for would be exposure to those chemicals and possibly the phosphine gas. That's a typical meth lab right there. That's what they look like. Junk, stuff, mixed containers with unidentifiable liquids in them, or they may be identifiable. I mean, I've been in a couple, not bragging, it's kind of idiotic. I've been in a couple thousand labs, and I could go in and pick up a jar and I'd say, well, this is what he was doing here, and this is what this part of the process was, and this is what the other part of the process was. These are the things that you see. These are the solvents that they would use. The jar there on the right would be one of the last stages. That's the separating liquid with the lye water on the bottom and the solvent at the top, which would contain the meth at this stage of manufacture. That's the gassing off apparatus. They would put the acid in the gas can or a soda bottle. They would put aluminum foil or rock salt in there, depending upon which kind of acid they used actually. And the fumes would bubble out into a jar and cause the methamphetamine to separate. Now, you folks in West Tennessee probably have seen this one more, and not as much these days, but this is what they use more in West Tennessee than in East Tennessee, because this process required the use of anhydrous ammonia, which is not as commonly found in East Tennessee as it is in West Tennessee. Anhydrous ammonia is typically used for fertilizer. Farmers go to the co-op with these big tanks that they pull behind the tractor and get it filled up with anhydrous ammonia, and they take it to their whatever they're farming and spray it into the soil, and it makes plants grow. It's a great fertilizer. We don't use it much in East Tennessee because we don't have any flat land and those tanks will fall over. But down there, this method became more popular because it's actually easier than the red phosphorus method and quicker than the red phosphorus method. Excuse me. Essentially, you take these three ingredients, your pseudoephedrine, which actually does not have to be separated this time. You take lithium or sodium metal, and the lithium usually is extracted from camera batteries, lithium camera batteries, and anhydrous ammonia, and you mix them in a bowl, and you stir them up, and they'll change colors, and it'll go from white to real dark purple to black almost, and it'll start turning white again as the anhydrous ammonia evaporates. And you stir it around and get all those things mixed together, and in about 5 or 10 minutes you have this kind of white sludge in the bottom of the bowl. Like the other process, you add a petroleum-based solvent to it, Coleman fuel typically. The methamphetamine that you've manufactured is absorbed in the solvent, and then you go through the same final step of gassing off of the can with the acid in it. So these actually were a little bit less dangerous probably than the red phosphorus ones. Well, some people say it's a little more dangerous because of the lithium. Most of you remember your high school chemistry class where the professor or teacher took a little strip of metal and dropped it in a little beaker of water and a big fireball shot out. Well, that was probably lithium, or it could have been sodium metal. So this process probably had a little bit more potential for a fire or explosion. But generally speaking, the amount of lithium was so small, and it was used up fairly rapidly in the process, that unless you dripped water into the bowl where you were cooking, the odds of it going off were pretty slim. Here's what we see today. These are the meth labs of choice. The one pot or shake and bake method. And they are incredibly dangerous. This is essentially a short version of the Nazi process. You don't have to have anhydrous ammonia. You can use ammonium nitrate. You can get that either from fertilizer or the cold packs I could get at the pharmacy to put on a sore or a wound. I mean, a sore place, your back, your neck, your shoulder, whatever. They contain ammonium nitrate or sodium nitrate. Either or work in the process. The difference between this and the Nazi lab is they put these three chemicals together, the same three chemicals. Well, ammonium nitrate instead of anhydrous ammonia. But ammonium nitrate, lithium or metal or sodium metal, and pseudoephedrine in a Coke bottle, like you see in this picture. They'll add the petroleum-based solvent, Coleman fuel, or sometimes use ether, which they get from starter fluid, which is hugely flammable, almost explosive, to that container, and they'll fill it about up, and they'll put, oh, I don't know, a little water in there. The water aids the reaction, but also intensifies the prospects of blowing yourself up. Let me see something here. I'm going to show you a very quick video. That's the stuff you would see laying around one of these types of labs. These bottles in the bottom corner all came out of one house. Each one of those represents a different meth cook. Those are all one-pot cooks right there out of one house. In the car, going down the road, they could do a one-pot cook. And let me see now, I'm going to have to figure out how to back out of this thing for a second. Well, David, how do I do it? Let's try that. No. Let's not do that. Bear with me. I told you I have no clue how. Let's see what that one does. Let's see what that does. Let's see what that does. Nope, that didn't help me. No, that helped me. Oh, grief, people. I'm sorry. This one, too. Okay. Bear with me just one more second.
Sullivan Smith here. Let me jump in while Dave's getting this fixed, but
just kind of my show.
In perspective, in terms of numbers of labs, last year in Tennessee, there were 1,800 seized in Tennessee. That makes Tennessee the #3 state in the union.
Okay. Okay, thanks, Eda.
Yeah, we parented.
Well, let's see if this will play. Here is, let's see if this will play. Why, no, it's neither of them are going to play. Here's what we look like. I'm going to go out of this in just a second, and I'm going to play these two videos for you. part of the issue is, and part of the concern with the folks in your realm, in the medical field, in the emergency room area, is the contamination of people and the cross-contamination between people. As law enforcement officers, in theory, when we go into a meth lab, did I do that? This is how we enter a lab. We are dressed in protective gear, and 99 times out of 100, when we leave the lab site, we do a dry decon, which essentially is taking off this gear, taking off this equipment, taking off this protective suit, and throwing it away in a certain type of containers. And we're deconned. The odds are, when we bring a person out of a meth lab environment, I mean, he's had chronic exposure. He is certainly going to have some amount of contamination on him. But typically, he is not contaminated unless he's got gross contamination, unless something's blown up or spilled on him. He's not going to be grossly contaminated to the extent that casual contact with him, that is, just touching him, is probably going to contaminate me enough to require any more than what I would do anyway after touching somebody like that, and that's be a good hand washing. You know, you guys in the emergency room were exposed to so much more stuff. I mean, you are prepared and equipped to handle bloodborne pathogens. So the odds of you getting something going wrong, you being affected by exposure to blood, is so much higher, in my opinion, than casual exposure to a person who's been in a meth lab. The officers, you know, they should be dressed like these folks in this picture are. And by the time they come to your emergency room with a person, you know, they are probably no more contaminated than you are. Now, one of the issues I've been made aware of, that there are police agencies in the state who bring everybody in the meth lab, or bring the defendants arrested in a meth lab, to the emergency room to have them checked and deconned. And the fact that they were in a meth lab, unless they're showing some distress, I'm not sure why. I mean, you probably need to let them know if that is their standard course, that you at the emergency room should not be held by the law enforcement people responsible for decontamination of a defendant, unless he is showing some kind of signs of a medical issue that needs to be addressed in the emergency room. Otherwise, if they're worried about decontaminating him, law enforcement should get the fire trucks there and hose him down and put him in a paper suit and take him on to jail. Now, children, and Sullivan's going to address all of this, children are the one exception. I've trained most of the SAM Lab certified officers in the state. Yeah, probably. We've got probably 2,000 or 3,000 now. I probably trained half of them anyway. And I always stress the importance and urgency of the children in meth labs, regardless of whether they're showing signs or symptoms of some kind of problem, should be taken to the hospital. Probably should be deconned. Just because their little bodies are more susceptible to the effects of chemical exposure than a grown-up dopehead. But so, with the exception of children, unless a defendant, a person who has been taken into custody by the police for manufacturing methamphetamine, is got signs that he's got a physical issue, my opinion is, he's theirs. He's the cops. He's not the medical professional's problem. He's the cop's problem. More likely, here's what you're going to have. You're going to end up with a guy who has set himself on fire, and now the EMS brought him to the emergency room, and and that you're dealing with a whole different issue. And anybody who's got burns, you know, the contamination, whatever contamination there might be, would be secondary to whatever the burns were. This is the one we don't want to have to deal with. This is the one that, without a doubt, will make it to the emergency room. And this is the one that we're seeing more and more of with these one-pipe method labs. I'm going to show you my quick videos now. John, I think I can pull this off now. This one shows the manufacturing process. I am going to turn the volume down on that. Actually, I'm going to skip ahead just a little bit here. He's going to put all the things in that grinder, in that bottle. He's getting the lithium out of batteries. But I just want to show you what the cook actually looks like when it gets going. He's adding lye to the mixture. Okay, now this, he's shaking it up a little bit, but this stuff starts moving around by itself. It gets real happy inside of that bottle, and you see it's boiling and it's moving. Now watch this. You see the little flames in there? That is moisture coming into contact with that sodium or that lithium, and those sparks are occurring in a bottle full of ether. That's what the cook looks like. Now, let me show this other one very quickly, and then I'll shut up and let Sullivan take over. This is a friend of mine who works for a hazmat company. They do this one-pot method. Watch closely. They just put in the last bit. The bottle is already expanding to where the bottom of the flask was round so it wouldn't stand up. That all happened within just seconds of when they got all the components put in that bottle. So that is the type of event that you folks will most likely have to be dealing with. I am going to shut up now and turn this over to Sully. I've enjoyed talking to you. I hope I haven't rambled too much. And I'll be around later for questions.
All right. Dave's a hard act to follow, but while he was fixing some of those things, I didn't know if it got through or not. But last year in Tennessee, there were 1,865 meth labs seized in the state. That makes us number 3 in the union. And in fact, if you actually break that data down a little bit, you'll find that several of our counties in Tennessee, if listed as a state, would actually be in the top 25 states in that list. Tennessee has a real methamphetamine problem. It's interesting. I know there's been a lot of talk about the legislation and control of pseudoephedrine, but in the 2 states, Oregon and Mississippi, where they've controlled pseudoephedrine, that is making it by prescription. You know how many meth labs there were last year in those 2 states combined? 11. 4 in one state, 7 in the other. We do, in Tennessee, that number of labs seized every 24 hours. It just kind of puts it in perspective. But remember, I'm talking about seized labs, which is truly just the tip of the iceberg, nothing more. There are scores of labs that go undetected, unknown to police, and it's a bigger problem. So stand by just a second. One of the things that Dave talked about a little bit was phosphine gas. I wanted to touch on it before I got too far away from that. Phosphine gas, the fellow who's lying in the motel room dead, it's a colorless, odorless gas. It's hydrogen phosphide. And you can't smell it. And it is a very toxic gas. It will attack your lungs and is very, very hard to tell it's there without a sniffer. And so by the time you can smell it, it's supposed to smell a little bit musty. By the time you can smell it, then you are well beyond the immediately dangerous to life and health threshold, and you're already in trouble. So starting slides, priorities for when methamphetamine comes into your ER. Stand by just a second. All right, I'm back. So let's talk a little bit about priorities on what to do when methamphetamine comes into your emergency department. And really what we're talking about are people that come out of meth labs. Who are those folks? Well, don't really know. You see a lot of people that are impaired, intoxicated, strung out, tweaking, whatever word you want to use for methamphetamine all the time, but you don't know if they came from a lab or not. You know, it's hard to say, but sometimes you know that they truly come out of a meth lab. Regardless, anytime you're dealing with somebody that has a methamphetamine problem, the thing to think about is your safety, and I cannot stress it enough. If you come away from this webinar with one thing, you know, you've got to be very concerned about safety, and the safety is from all sorts of things, in particular violent acts. These folks are very unpredictable. They're phenomenally strong. They're often hallucinating or delusional. They're paranoid, and just within the blink of an eye, they can go into launch mode and become very, very violent. So, you know, the priority in my mind is to keep everybody safe, and that includes the guy that's strung out on the methamphetamine. ABCs always, you know, an issue when you treat patients. The ABCs stand on their own. You get those drilled in your head every day about things, and I'm not even going to touch on them. We're going to talk about decontamination and what you do, and then if time permits, we'll talk a little bit about therapy, how you treat these folks who are on the methamphetamine. All right, let's see. We got to make this advance. There we go. Wasn't hitting my arrow hard enough. So safety. I mentioned the unpredictable behavior. I don't know how to tell you this, but these folks can launch the blink of an eye. Just something that goes on outside the room can be enough to set somebody off who's a little bit on edge. And they can become suddenly violent and phenomenally violent. You know, Tim McVeigh is probably a great example of a very violent methamphetamine abuser. Probably the most infamous methamphetamine abuser in the history of the world is Adolf Hitler. You know, these folks can do some very, very terrible things. They become phenomenally strong, and you know, they just have that that sort of strength that, you know, when the child's under the car and the grandmother lifts the car off the child, it's that sort of strength. We had one methamphetamine addict in my emergency department in a seclusion room that, without even putting his foot up against the wall, jerked an 800-pound magnet door open. And he, you know, he probably weighed about 150 pounds. And then the fight was on. But, you know, it's just hard to describe unless you've seen it. You got to think about weapons. These folks are paranoid, and oftentimes the weapons that they carry, they bring into the emergency department if somebody hasn't searched them. So if they come from a lab in the custody of law enforcement, that's one thing. but when they walk in your front door, that's another. And so you've got to think about weapons. It's often multiple weapons, multiply armed, not just one, not just two, but sometimes even more than that. Guns, knives, all sorts of things. Paranoid. They're trying to protect themselves. They're trying to protect their dope. And it's pretty spooky sometimes. The other thing, though, about weapons are, what are the weapons in your room? What could they use against you? An IV pole pulled off of a bed makes an excellent club. There are all sorts of things in the room that you ought to take a look at after you get done with this webinar. Go back to your emergency departments and take a good hard look at the things that somebody could use against you in that room. While you're thinking about the room, you got to think about where you are. This is a area where you've got to be very cautious and very contemplating about your position in the room. Where are you in relation to that patient? You should absolutely minimize any time you're within striking distance, and that's not just with fists, but also with feet too. You've got to stay out of range where somebody can hurt you. You also have to think about, where's the door? Where's the patient? Where's the door? And if this goes south, how am I going to get out? How can I evacuate? If you're in the corner and then the patient's between you and the door, you've got trouble. If you're in that spot, and sometimes you can't help it, what do? Have you got some way to call for help? Our hospital uses a product called Vocera, and we can call for help with that. Would you push a code button? Would you yell? Do you have a cell phone? Might be a little hard to use that cell phone when somebody's on top of you while you're trying to dial a number. But think about this in advance and have a plan. The best thing is to always have a number of people, as many people as you can foster in that circumstance to go in the room with you. The more people you have, the better your chances are of escaping an altercation unhurt. But there's also a bit of a persuasive effect where people don't tend to fight 10 people where they might want. So deal with these folks in numbers, and anytime you have the opportunity, invite your security or your local law enforcement to visit with you during these episodes to help you in these situations. They have special tools and techniques where they can restrain people, perhaps place them into custody, or certainly help hold somebody until you can achieve some control of that patient. Decon, really the topic for today. There have been so many different stories about how you decon these folks. I've heard about whole departments being quarantined, and then they expanded out into the lobby, and then they expanded out into the ambulances, and then the personnel in the ambulances, and registration clerks having to be deconned, and clothes being destroyed. And that's pretty disruptive to your department. It's pretty traumatic to those who are involved. And as we've come to learn about meth labs and meth exposures from labs, it's just not necessary anymore. There are a lot of thoughts that you have to do all these terrible things to decontaminate people. And if you've ever been through a decontamination class where you actually get deconned for real, it ain't fun. It's not good at all. Don't get me wrong. Meth labs are really, really bad places, and they're very dangerous places, and the meth addict can be a very dangerous person. I'm not saying these aren't dangerous situations, but in terms of decon, it actually works very well that you can do less. There's a tremendous body of research being done on this. A lot of it's being done out at the National Jewish Research Hospital in Denver, and they've actually done cooks. They have an old motel that they worked in, and they actually cooked dope and checked for levels, and then they worked with the contamination issues, and what does it take to clean one of these up? But in particular, what does it take to clean up these people? And what we found is that the cross-contamination is a lot tougher than we first thought. We first thought it was very, very easy, and now we found that it's really not that easy to contaminate others. So when that person's brought into your emergency department, in terms of decontamination, sometimes less is more. This kind of came about because of concerns of schools and family members. You know, what do you do with a kid who comes out of a meth lab? Well, you know, he went to that grade school and he was in this class and he ate in the cafeteria and he played kickball with all the other kids, and you know, so do we have to decontaminate the kids? So people actually went in and looked at this sort of thing, and they found that the answer is no. The contamination from a meth lab in those schoolroom settings, you know, those daycare settings, in those households where maybe somebody was in a lab and they went back to another home, really don't exist. You know, the contamination is minimal, and the cross-contamination is even less. So, you know, what you need to do is establish a process. And, you know, by establishing a process on the front end, you're doing it during working hours, never, you know, at 2:30 in the morning or on Sunday afternoon when nobody else is around. It requires some forethought, and it requires putting all the stakeholders together. Once you get that process, it's important that you follow it. You know, and in order to follow it, you have to educate all the people who would be involved, and, you know, and that includes all walks of life within your hospital and within your emergency services community, whether it be fire, rescue, law enforcement, you know, children's services. There are all number of people that play into this process of dealing with a methamphetamine patient in the emergency department. They all have to be involved. How about children and protocols for children? The question is, do you have a protocol? Very few counties in Tennessee do. There are 95 counties, and last time I looked, there were maybe 14 or 15 that had a protocol, and there are varying degrees of protocol. Some of them are very limited in their scope. Some of them are very detailed. But a protocol for children is really pretty important, because in the meth labs I've been in, and I've been in hundreds, not as many as Dave, but I've been in hundreds, there are children in probably 30–35% of the labs that I've been in. We got to take care of these kids, and they have special processes in terms of children's services, placement, and all those sort of things. Plus, these are growing brains and lungs and livers and hearts and kidneys and things, and you know, we've got to protect them. So I would heartily recommend that you create a separate protocol specifically for children. You know, the purpose is to establish who does what. Is that law enforcement's responsibility, or is that children's services that does that? Or do nurses do this, or do we let family members do this? And so there's all sorts of things, but you've got to work through those responsibilities, and everybody needs to be on the same page before it happens. Again, you know, not something to try to figure out Friday night when you're having to wake all these other folks up who aren't there. You know, it should flow smoothly. It's to the benefit of the children if it, you know, moves smoothly, and you know, it works better. So the one I would recommend is you can find at that website. It's the Tennessee Alliance for Drug Endangered Children. Okay, and at that website there is a protocol for how you deal with a child that has come from a meth lab. It follows the National Drug Endangered Children's guideline, and it's based on science, and it really works pretty well. Just as a matter of disclosure, I am a board member for the Drug Endangered Children's Alliance in Tennessee. You know, I don't see that it's any sort of conflict, but I figured I ought to tell you about that too. All right, so the actual decontamination, like I said, it's changed quite a bit. You know, we used to torture people with all sorts of decontamination things, and we actually got where we knew how our showers worked and such in our decon rooms quite well, because we used them pretty regularly. Now we don't use them so much. A dry decon, basically taking their clothes off and putting them in something else, is usually okay for somebody who looks otherwise well. And by otherwise well, I'm talking about in terms of chemical exposure. So, you know, what we do is we take their existing clothes off, we put it into a biohazard bag or some sort of a non-permeable bag, and then we place them either in a hospital gown or in some disposable scrubs or something like that. Children, sometimes we will wrap them up in blankets. Just kind of depends on quite where the situation is. It's a little hard to have disposable scrubs for kids, but we do have some clothes that have been donated by some very charitable folks here in our community. You might want to check into setting something up like that in your community, where you have different sizes of clothes for different sizes of kids, and then, of course, kids come in two makes, too. You have to figure out the girls and the boys both. But being able to put them into some real clothes is really a very kind thing and seems to work quite well. Might shower people. We tend to shower children, or at least wash children, because we're a little more concerned about them. Long-term effects of methamphetamine and methamphetamine labs on children are unknown. There's some pretty good research about meth effects on children, but it comes out of Thailand, and in Thailand the children are smoking methamphetamine. Well, in Tennessee, not too many people smoke it. They tend to use a needle. But secondly, these kids in Thailand are not growing up in a meth lab. The chemical contaminations there are real. These are nasty places. I don't know how to explain it to you, but perhaps to tell you that, you know, in my history of going into meth labs, I've never seen a roach, and I've never seen a rat in a meth lab, and I think it's because both of those animals are survivors, and they know to get out of those sort of places because they are just terrible. You know, cockroaches have been around since the time of the dinosaurs, and they know enough to get out of a meth lab. So spills are real. Spills go to the floor, you know, and that's where kids play. They play on the floor. They crawl on the floor. These chemicals are oftentimes stored in bottles, like you saw in Dave's presentation, that are used for drinks, sun drop bottles, all sorts of things that could easily fool a child, and they might mess with it or even consume some of it. And you know, it's a particularly dangerous place. So I think to wash a child gently is not a bad thing to do. We actually have done this in our emergency department in Cookeville more than we'd like to own up to, and we have a process down that's pretty good. You know, some people will argue that it's traumatic on children to decontaminate them and even to test them for medical issues related to the lab. We would disagree. We, in fact, take children who are sullen and withdrawn. Remember, you know, the police came in. It was oftentimes a fairly violent sort of event when a meth cook gets taken into custody, and that's the only family these kids know. So they come in and they're angry and they're withdrawn, and you know, they come in out of a very, very violent place, and in that couple hours they spend with us as we work through the process and find out where they're going to go in terms of placement. These kids absolutely blossom, and they smile and they play. Even though they've been poked with a couple needles and they've been washed by a stranger, they absolutely become children again. And it's amazing, too, how much they can eat. You know, we found that children are oftentimes very malnourished in these labs because they're neglected and oftentimes abused. And we found it to be a very rewarding process, and we're very proud of what we do, and we'd be happy to share that with any of you that are interested. As you think about decon, it's important to know what was done pre-hospital. As Dave Shelton told you, oftentimes these folks are dry deconned or field expedient deconned at the scene. And that basically talks about the same thing we're talking about, removing any contamination, you know, by removing clothing. It's okay to wash exposed skin if it's very easy to do that. Obviously, if somebody has greater contamination, then you know, you need to treat them just like you would any other chemical exposure. Think of a meth lab in terms of decontamination as a really, really poorly run chemical factory, or maybe a chemistry lab from a school somewhere. That's what we're talking about. We're talking about acids, we're talking about bases, we're talking about solvents, we're talking about some pharmaceuticals but these things are not managed well. They're not stored well. They're just sloppy, terrible cooks, if you would. And so if somebody is grossly contaminated, think about what you're dealing with. And if this were a disaster at some chemical factory somewhere, you would run them through a decon process that you all know so well and have to have set up. So the grossly contaminated person, they need to go through a regular decon. And, you would wash them down and take care of them just like you would any other chemical exposure. Barrier protection, probably a really good idea here. You certainly don't want to splash this stuff on you. Some of these things are very caustic. You remember the two-layer fluid that was the meth oil and the lye water wash. That lye water has a pH of about 13. The scale only goes to 14. It is very caustic, and it will burn you. Remember, it's an alkali, and alkali burns are significant in that they tend to continue to burn despite your decontamination efforts. Those alkalis bind with proteins, and so they're a lot harder to wash off or brush off, as the case may be, and they require considerably longer showers and washes in order to try to dilute that burning process out. There is no need to quarantine the ER or the staff. Okay, let me go over that again. No need to quarantine the ER or the staff. Heard all kinds of stories about somebody walks in from a meth lab, and they burned their hand, and they walked into the lobby, and they quarantined the lobby, and they made the registration clerk decontaminate, basically disrobe and shower, and then throw the clothes away. These chemicals don't jump off of somebody and onto something else. There are no pogo sticks here. And so, it's just absolutely unnecessary. Now, you might want to wipe down surfaces if that person sat down in a chair. You'd wipe it off like you would if somebody spilled something. But really, that's what you need to do, and nothing more. Nothing more. To quarantine ambulances, unnecessary. Quarantine law enforcement officers, unnecessary. To quarantine the nurses and the docs and the respiratory therapists and all the other staff that take care of these patients, unnecessary. If you use universal precautions and you protect yourself as you should be okay. You would clean the room up like you would any other room unless there was some sort of contamination that got on surfaces, and then you would clean it up as if it were a spill of any other chemical or blood. It's pretty easy to do. The basic thing, to recommend is to use some common sense. You have protocols in your hospital, and those protocols don't address every single issue, but they give you some good guidelines. And when it steps outside of your protocol, then just use some common sense. If you're across the room from somebody that's been in a meth lab, you don't have to decon. If you use some barrier protection, a gown, some gloves, you shouldn't have to decon, unless you have a direct contact before the decons happen. Just some basic common sense should really be your guide in terms of what to do there. What about belongings? We used to say nothing comes out of a meth lab. Never, ever, never, ever, no way, no how. Well, not so true anymore. And that's particularly important as we looked at children. Clothes to children are status things. Which sneakers do you have and what kind of jeans do you wear? And for adolescents, and a lot of these kids are adolescents, backpacks. Your backpack is your identity in school many times. And so, there's been some pretty good research in this. Clothes are okay. They can have them back. But they need to go in that impermeable biohazard sort of bag. Backpacks may be okay. And, what you have to do is consider what can you clean. And the recommendation right now is in a washing machine, clothes, you run through 3 times. Run 3 specific cycles. And then after you take the clothes out, they are good to go, and the kids can wear them again. It's recommended that before you put anything else in the washer that you run a empty cycle where it's just soap and water to wash the washing machine out before you put other clothes in. Well, that right there shows you that wiping surfaces down is okay too, because it's just soap and water that you run through that washing machine, you know, and then it's good to put in other clothes and things. Now the backpacks, I say may, because it depends. Are they padded or not? You know, what about the shoulder straps? And, you know, do you really think you can get them clean or not? So backpacks may be okay. Clothes are okay. Plush toys, stuffed toys, you know, teddy bears and that kind of thing are never okay, because you simply cannot clean within the substance of that toy, and so you can't take it out. Something that was perhaps, you know, plastic, wipe it down, wash it good, should be okay. It's the porous objects that are a problem. And, you know, the one that's never okay are the stuffed animals and the stuffed toys. You know, again, we keep a supply of those in our emergency department. We try to replace some of those with children as best we can. It's not that teddy bear that the kid grew up with, but it's another one. Sometimes we introduce them to their new friend, and it works out okay. It's not the best, but certainly the safest. Okay. The last bullet on that slide is it evidence? In particular, that's an issue with children. Now, you got to realize working meth labs has changed quite a bit from when we first started doing this. And I went through Plan Lab school back in 1998, and you know, we didn't have some of the luxuries we do now. There are ion scanners now that respond to meth labs and can test children, and basically the surface of the clothes and surfaces in the house that children are exposed to can be tested, and it tells you what's there. So sometimes clothes are maintained as evidence, and again, particularly with children, because you're looking at all sorts of child abuse, child endangerment issues, and potential custody issues going forward. But that may have already been addressed with that ion scanner, so there may not be a need for those clothes as evidence. On the other hand, there could be. You know, perhaps the clothes show signs of abuse, where there's dried blood from a wound or something like that. So before you give anything back, or before you destroy anything, as you would any other unwanted material from the emergency department, you probably ought to check with your law enforcement if involved, or if they need to be involved, and not dispose of anything in any way until you've conferenced with your law enforcement folks. That's part of that protocol. You know, if you sit down and talk about it on the front end, it makes it a lot better on the back end. A little bit about what these people look like when they come in. Signs and symptoms. Most of you have probably seen some of this. It's amazing, as many times as Dave and I have given these talks, how many people still haven't seen methamphetamine, or maybe they just didn't recognize that they saw methamphetamine. One of the classes that we taught years ago, we were showing what a meth lab looked like, and had a law enforcement officer tell me that he wished he had seen those slides just the week before. He had made a traffic stop and had this big bottle of something. He didn't know what it was, and they poured it out on the side of the road. It turns out it was meth oil. Most likely it was a 2-layer liquid and smelled funny, and the guy acted like he was strung out on something, but the officer didn't know what he was dealing with. So hypertension, we see some phenomenal hypertensions. You know, I've seen blood pressures in the systolic, you know, 230, 240, 260 range, just extremely high blood pressures. Tachycardia, fast heart rates, resting heart rates, 160, 170, sometimes, you know, 130 at others, but, you know, fast heart, high blood pressure, high body temperatures, hyperthermia. I think the highest one I've personally seen is 105, but they've been reported to have temperatures as high as 107 before. You know, and all of this is driven because of it's the drug, and it's the drug's effect on your brain. This is a sympathomimetic storm. You know, it is ultra speed, and because of the effects on the brain, that's what makes the heart run fast. That's what makes the high temperature. That's what makes the blood pressure high. Altered mental status, touched on that a little earlier, but a lot of delusions, a lot of hallucinations, a lot of paranoia. You know, and actually methamphetamine, it was about 4 years ago, it was out in the Midwest. There was one state where methamphetamine was related to more domestic violence than alcohol. It was over half of their domestic violence cases. And these people become very paranoid, and as they become paranoid, then, you know, they're worried that the president's going to show up, and then they're worried the DEA is going to show up, or the FBI, and then they start worrying about the TBI, and then they start worrying about local law enforcement, you know, and this circle keeps getting smaller and smaller as a rule, and then, you know, it turns into the house, and people actually talk about how the cook becomes very paranoid that they're going to snitch and rat them out and things, and so it becomes a very violent and dangerous situation in the home. You know, domestic violence is very high with methamphetamine. I personally know of a kid who, during a cook, was not allowed to go outside and play. And, you know, these cooks, this was back in the Red P day when it took hours and hours, and the child picked up a toy not thinking and was headed towards the door, at which point the meth cook held a knife to this kid's throat for 8 hours until the cook was completed. A lot of agitation. These folks are very restless. They have ants in their pants. They can't sit still. They're on the move all the time. Oftentimes will have seizures. They can have chest pain. And chest pain is worth talking about because it's a separate process. It's not coronary artery disease as a rule, but instead it's spasm in those arteries. And so you got to treat it a little differently. You know, it's not somebody that needs to run to the cath lab and get TPA and all that sort of mess. Instead, they need sedation and nitroglycerin, and we'll talk about that. Very dilated pupils. I used to think they were the biggest pupils in the world until bath salts hit the street. And bath salt pupils are just even bigger. But very dilated pupils, a lot of rashes. We don't really know what the rashes are because when we test meth labs until recently, we've looked at it forensically, meaning we're looking at it in terms of building a law enforcement case. And so we're looking for the red phosphorus, or we're looking for the anhydrous ammonia, or we're looking for the ether and the lithium and the pseudoephedrine and those sort of things, you know. But in these processes and the spills and the contaminations and, you know, none of the chemicals, excepting the pseudoephedrine, none of the chemicals in there are USP grade, meaning that they're safe to put in your body. So, you know, there's all sorts of contaminants and things in there that just don't play well together. And so some of the rashes we think are actually from other contaminants and chemical reactions that we really haven't paid a lot of attention to because, again, we've been trying to make a law enforcement case and not so much a health-related case. The rashes are sort of nonspecific. Oftentimes people say they burn. They're typically red. They're kind of confluent. Sometimes you get blisters. Sometimes you don't. All sorts of different shapes, oftentimes on exposed skin, but they're just kind of nondescript rashes. Dental decay is prominent. A couple things. One is their nutrition is pretty poor. Two is their dental hygiene is worse. And then three is because of this sympathomimetic storm, all this stimulation to their brain, their mouth's dry. They don't create as much saliva. And saliva is very protective for teeth. And so these people will lose teeth at an alarming rate. Their dental decay is even more alarming. One officer that I spoke with a couple of years ago was interviewing a meth cook, and during the process of about a 30-minute interview, 4 of his teeth fell out onto the table. It's dramatic. Weight loss, you know, this is speed. People don't eat. They stay up for days at a time. And so dramatic weight loss is not uncommon, sometimes 20, 30, sometimes 50% of their body weight in a matter of a year or maybe a little more. It's not uncommon. And then the violent acts. Geez, you know, carrying weapons, very paranoid, you know, and now you've got official people in your emergency department or perhaps with EMS or law enforcement who show up with badges and things, and that's the exact people that they're afraid of. And so these oftentimes lead to violent confrontations. And, you know, it can happen in that exam room too. You know, you could be in there and things could be fairly calm. And then somebody walks by the room outside and makes a comment that the person overhears and thinks maybe about them, or somebody laughs about something outside. And suddenly the fight is on when you had no idea that it was coming. Phenomenal violent risk, phenomenal violent risk. What about excited delirium? Well known to be associated with methamphetamine. Originally was seen more with crack and cocaine, but it's actually it's a really interesting topic. There's some really good debate about whether this is truly a diagnosis or is it a syndrome or just what is it. But the fact is it's real, and it does happen. You know, what you see is just extreme agitation. There's some really good videos of what excited delirium is. If you go to, if you Google Palm Beach Police Department excited delirium or Palm Beach excited delirium death, there's actually a video, and it's way too long for this presentation, but it shows a fellow who dies of excited delirium, you know, and he's extremely agitated and very aggressive, you know, and obviously very distressed, and he's running around, he's screaming, he's posturing very aggressively and very defensively and things, and then suddenly these people die. And so, you know, what you see is this tremendous aggression. And in the cases that I've looked at, and I've been involved in a couple of these sort of things, these individuals will generally rip off every stitch of their clothes. I'm not sure why that is. I don't think anybody really knows, and the studies on excited delirium are really kind of limited, because how do you study something like this? But these people will rip off all their clothes, which makes it tough for law enforcement and anybody trying to control the situation, because now, besides being aggressive and phenomenally strong and very sweaty, there's nothing to grab onto much. And so they're very, very difficult to control, and oftentimes the struggle is phenomenal. And then once the subject's in custody, he's restrained, doesn't have to be, you know, handcuffs. He could be in 4 points on a bed in your emergency department. And then suddenly they become very quiet and very still. And as soon as that happens, you're in trouble, because the code, you know, the cardiac arrest is going to follow soon thereafter. It is a potentially avoidable problem. I guess if you didn't use drugs, that would be the best way to avoid it. But you've got to deal with this very, very aggressively in terms of therapy. There are a long list of drugs associated with it. Psilocybin mushrooms have been reported to cause this. I think Motrin's even on the list. You know, and it's just phenomenal what can cause this. But you know, the end result is the same sort of behavior, and then potentially death. There's some research looking at dopamine receptors. There's all sorts of chemical transmitters they're looking at levels of. Nobody really knows for sure. And in fact, there's a foundation in Florida for people that die of excited delirium, or what's thought to be excited delirium. They're asking that you send brain tissue down there so they can study it and figure out what to do with this. Talk about the treatment in just a minute. But you know, the key here, I keep talking about safety, is don't get hurt, because it can happen. We had a recent case up here where an excited delirium patient bent a set of handcuffs, broke them where they wouldn't work. Just hard to believe that somebody could be that strong, but they actually did. So, you know, deal with this in numbers. The best thing to do is just, you know, if you recognize you're in this sort of a situation with a patient, you know, back away and get lots of troops to go in with you to address the situation. Certainly not 1 or 2 or even 3, but you know, the more people you can get, the better off you are, and the better the odds are that nobody's going to get hurt. And that's the individual as well as your staff. You know, treatment just depends on what you do with a methamphetamine patient. You know, if they're asymptomatic, they really don't need much. They don't need much of anything at all. They may be wild and woolly, which is the excited delirium sort, or the person who's paranoid and delusional, you know, but have a low threshold to treat. You know, if you think things are escalating, if the patient's spinning up, if it looks like he's on edge and you're worried that he might launch and become violent, then, you know, that's the time to start treating this patient. It's not after, you know, the fight is on, but it's before the fight. That's clearly the best solution to the whole problem. So what do? You give them IV fluid. Saline's the right thing to do. You give them a lot. Some protocols I've seen say for an adult you give them a couple liters. Some say you give them you know, 20 per kilo or 30 per kilo. These folks do tend to be rather dehydrated. They've been up sometimes for 24, 48 hours. They tend not to eat. They tend not to drink. And because of that, they're volume depleted. That has a lot to do with tachycardia. That has a lot to do with hyperthermia. They can develop rhabdomyolysis too. And so IV fluids are really important, help in a lot of ways. Sedation, lots of sedation. We use midazolam or Versed here more than any of the others because it tends to be a little more sedating. But it really doesn't matter, whatever you have. The question is, and people ask me, how much do you give? And my response is, how much do you have and how much do you need? Personal records are somewhere in the order of Versed, and this was actually a 14-year-old patient who got 140 milligrams of Versed in an hour and was still awake and talking. You need enough to control the situation. And so sometimes, they're very, very, very large doses. It's something that's important to talk about with your EMS. Our EMS in Putnam County now carry considerably more Versed and Ativan than they ever carried before, simply for these sorts of patients. Sometimes it is beneficial to add a low dose of a psychotic, an antipsychotic medicine, but you have to be careful there because seizures are a real possibility, and most of those antipsychotics lower your seizure threshold and also impair your thermal regulation, so it makes it harder to control your body temperature. Remember, these people have seizures and high body temperatures, and so these drugs are really second line if you use them at all. Most of the time you can get by without them, but you may need to consider a low dose of an antipsychotic medicine like Haldol, something like that. Beta blockers are bad news. Most times when people have fast heart rates and high blood pressures, you think about a beta blocker as a great drug. But but methamphetamine has alpha and beta effects. And if you give a beta blocker, then you can have unopposed alpha, which can make blood pressure just skyrocket. And so, it's really best not to give beta blockers. It's even been reported to be fatal that you give a beta blocker and then you have blood pressure that causes a fatality. If you must use one, probably labetalol is the best one because it has the alpha effects as well. But by and large, you can get by without a beta blocker. Sedation and hydration are the two keys of therapy for sure. For chest pain, remember, it's not coronary artery disease, but it's spasm, and nitroglycerin is probably the best thing to use if the benzodiazepines don't address it, and oftentimes they do. This is not somebody to give lytics to. This is not somebody to give blood thinners to, particularly with those sorts of blood pressures and things. You can make matters a lot worse. So if you have to give something, nitroglycerin is best. One other note on chest pain, and nobody's really sure. They think maybe because of the blood pressures, they think maybe because of some of the solvents and, how they work on blood vessel walls. These folks are also prone to aneurysms and aneurysmal dissections, dissecting thoracic and abdominal aortas. And so blood pressure control is very important in them, but picking up on that is pretty important too. A chest x-ray, checking pulses, all the typical things you would do if you think about a dissection are important. Just keep in the back of your mind. If it's a methamphetamine patient who's very young and he's telling you his chest is killing him, don't blow it off because the guy is 18 years old. Pay attention to him, and if he looks gray and ashen, you need to start thinking about where your defibrillator is. Treatment, the evaluation is mostly supportive. There's no antidote to this. The folks that are asymptomatic really need hardly anything. And in fact, somebody's come out of a meth lab and they're brought in by law enforcement, they're asymptomatic, they really don't need to be there. Those folks don't need to make a trip to the ER, okay? Symptomatic patients, though, very different. What sort of test do you do? The third bullet point there lists several that are pretty standard in our department. There's some debate about what to do, and particularly with children. How much do you do? How much do you not do? Is it traumatic? Is it not? I think identifying the issues medically with patients out of these labs is fairly important. just as important and but however lacking in Tennessee is the long-term follow-up. It's very difficult to follow these children once they get into the system, and then they drop out of the system pretty quickly, and so we don't know how they do long-term, and so I'm trying to identify folks I think will be at risk long-term on the front end and early, but there's some pretty good debate about it right now, and the answer is not clear. Drug screen, it's important, particularly for children, but you got to know which one you're doing. And early in the methamphetamine epidemic, we had children that came into the emergency department and their drug screens were all negative, and it didn't make sense to us. We had a couple like that, and we knew they had to be exposed. We knew it should be in their urine, and we didn't have it. And so what we found out, by looking at our tests, which we did pretty quickly, the drug screen that's in most of your emergency departments has a cutoff. And below that number, it's read as negative, and only above that number is a positive. And so, the question I would pose for you is, what is the acceptable level of methamphetamine in a child? And of course, the answer is 0. Well, that's not what your drug screen and your ER tests for. So, we sat down with our lab folks. Again, this is part of our protocol, and we established responsibilities and how the process was going to work early on. And we found a send-out urine drug screen that has a 0 tolerance. And so now we send those out, and obviously we're seeing the results that we expected all along, where more children were contaminated by methamphetamine and had it in their system simply from being in the lab. So set this up when you get back to your day job away from this webinar, and talk to your lab folks and make sure that you have the right test. The standard screening test in the emergency department will simply not cut it, and particularly for children. Many of these drug screens come back positive for many drugs, but when it's positive for methamphetamine, it's oftentimes positive for amphetamine as well. And why is that? Well, it's because amphetamine is a metabolite of methamphetamine in your body. And so if you see somebody who has methamphetamine and amphetamine, it tells you it's not an acute intoxication, that either there have been exposures in the past or perhaps this is a chronic exposure. But when you see both methamphetamine and amphetamine, the chances are that it is just a metabolite. Obviously, people could be using something like Adderall and have amphetamine as well, but most of the time it's not that case. It's just a metabolite. And that brings us to about an hour and a half, and I guess I'll turn it back over to John, and we'll try to answer some questions.
All right. Thanks, David. Thanks, Dr. Smith. We appreciate it very much. Before we start taking questions, I'd like to cover just a couple of things. One point is that this presentation and the slides will be up on the THA website probably as early as Monday, and so you'll be able to take the slides from there. Also, we have a couple of documents. As we talked before, there's really not a whole lot of protocols developed yet, but Dr. Smith has volunteered to help set up or develop a model protocol, and I think we'll have him do that. Obviously, he's very knowledgeable in this area, and I think would be very helpful throughout the state and probably throughout the country. So we thank Dr. Smith for volunteering to do that. The two documents you will find on the website right now, one is an OSHA document, deals with best practices for protecting EMS responders. That whole document there, it's a 2009 document, covers all kinds of chemical types of incidents that you might run into. And again, as we said today, a lot of these types of meth issues are handled just like any other chemical exposure. So, and the other document we have in there is the Lincoln County City of Fayetteville that has a field operating guide dealing with methamphetamine labs. So both of those two documents hopefully will we'll give you you know, some other information, and then some of the websites and that were mentioned in the presentation today. So the first one, if we have questions, just go ahead and type those in on your dashboard, and we'll have either David or Dr. Smith give you some answers on that. As we say, okay, first question is, what is the average number of confirmed meth patients are sent to the hospital per week or per facility? I don't know, Dr. Smith, Dave, do you have any stats on that at all? I don't know if there any exist in the state. Maybe the methamphetamine and prescription drug task force might, Dave. I don't know. What do you think of that?
You know what? I'm not familiar with any stats specifically related to. We talk about people who are ultimately brought in by law enforcement or something and then admitted because of the meth issue.
Yeah, it probably both. You know, self-presented and brought in by probably.
You know, beyond the drug overdose, where they might be hospitalized, or where they were injured or significantly contaminated, where they got chemical burns or injuries or fires, I'm not really familiar with any being actually. I mean, I'm sure there are some, but I would say not a huge number are admitted just because of the drug problem.
I'm not aware of any numbers either. You know, it was kind of, we saw a lot of it back in 2005. I mean, it was just all the time, and it kind of dropped off a little bit, but anymore it seems like it picked back up at least to the level it was prior to the Meth-Free Tennessee Act in 2005, you know, back during Bredesen's administration. It really has picked back up, and I'm a little surprised by that, but I'm not aware of any numbers either. We don't even have hard numbers on how many children we took out of meth labs last year.
Okay, there's a question as far as CMEs or AMA credit, and we do not have any accreditation for this particular presentation. Okay, do we have any more questions for either one of the presenters? Okay, seeing no more questions, I would like to thank both Dr. Sullivan Smith and David Sheldon for their time and effort on this presentation. I think you got a very thorough, for a short period of time, overview on the meth problem here in Tennessee, and also some of the decon hospitalization protocols. Again, Dr. Smith has volunteered to help write some of those protocols, and so we'll take him up on that and get that out to you as soon as we can. And if you have any questions or anything, we can take care of that and make those contacts for you. So appreciate everybody's time on for the webinar today, and hopefully the information you got here is beneficial in your operations. So thank you all very much. Have a great day.